Alright, so we're going to look at the continuous random variable here, which again, as you'll see, is 9.1, and we've been charging on. So some people do this before they do probability, but I think it makes more sense to do it afterwards, after we've dealt with some probability. What type of data are we dealing with here? Continuous, which links more closer to the normal or the binomial distribution. It was a 50-50 chance, unfortunately you missed out. The normal. Remember the normal deals with continuous data. So it's close, more closely related to the normal because we're looking for an area. What's the process by which we look for area under curves? Integration. Now before we go any further, it's really important because a lot of these questions will ask, make sure that this is a continuous random variable or probability density function. They might say something along those lines. It must have these three markers to be in this category. So it must be continuous. What does that mean? Can't have any breaks. So if I'm sketching my function, this wouldn't be a continuous data set. Why is that not continuous? Well, why is that not continuous? Because at that point in the middle, they don't meet up, correct? So it needs to be continuous the whole way through. It must be positive. Why must it be positive? What are we dealing with here? What's this all about? Area and P? Probability. Always must be positive. Must be above the y-axis, x-axis. Because is it possible to have a probability of negative something occurring? What's the lowest probability you can ever have? 0. Correct? We can't have a negative probability. What's the highest probability we can ever have? 100. If I was to sum all the probabilities, right? So, if I was to add, let's do all the probabilities of Sam's future career paths, what's the summation of all those career paths? What do they equal? 0. That's one of the options. Unemployed is one of the options. 1. Okay. So 1 is the summation of all the different career options he has. Sweet? So the highest probability which means the total area must be equal to 1. So when we're dealing with these probability density functions, we must make sure they're continuous, always stay above the x-axis and have an area total that is 1. They're almost always piecewise functions. Remember piecewise functions in year 11? Cool. And you're probably going, that's all well and good, but what does that mean? This is the first question in the exercise. It gives us a function, it gives us what's next to the function. Sam, what's this? Range? Domain. Set of x values. What does this mean then? No idea what this means? But weren't you taught this by the master? Piecewise functions. This means between 0 and 1, the function is this.
Oh, yeah.
Any other time it's equal to 0. So this is going to have a quadratic looking graph in this range, in this domain. We don't need to determine that it's a piecewise because the question states that we're dealing with. Sorry, we don't need to determine that it's a continuous random variable because the question states that it is. So all we have to do is determine that x is less the probability when x is less than 0.5. So if I wanted to do that, how would I set that up? What operation am I using? Integration. What's my lower bound?
0.
What's my upper bound?
0.75.
And because it's tech active, just shove it into your calculator. We'll deal with that in a second. And what we get? 0.72. 5? 72.5%.
Wait, do you have to integrate it first?
Well, if I show that in my calculator,
And then I'll integrate it.
yeah.
Okay.
I did it the other way with my other class and they got confused, so. If I deal with question C, I'm going to skip one and go to question C. It says determine P x is greater than 0.25. Now what do I do? What's that?
0.75 to 1.
I go 0.25 to 1 of the same function, correct? And what does that give me, Paige? Can you hit the SD button? That's right though. What is that?
0.768.
Okay. So Paige has brought to our attention something that I wanted to bring up. What can you tell me about those 2 points? 0.75 and 0.25. If this were a normal distribution, what would we expect? What are normal distributions? How do we know this isn't a normal distribution, first of all? It's continuous. Its area is 1, but what's different? Is it symmetrical? We can tell it's not symmetrical here because these values would be the same if it was symmetrical. Sweet. Similar idea to the normal distribution. We just can't use the z-scores and the same rules that we use, but it's a similar process. We're finding the area under the curve to determine the probability. Now question 3 and I think question 4 have got a few challenges. So if we look at question 3, I'll do this one quickly. I don't want to do the whole example. But I want you to look at question 3, C I think it is. So question 3 is on the board. What's different about question 3? What do we notice is different to question 1? Function a bit different, but that's not where I'm focusing. The domain, what's different about the domain? X is greater than 50. So in this situation, we easily can set the upper and lower bounds because we had those clearly stated. What's going to be the challenge with question 3? When we're looking for an upper bound, it's going to be very challenging, isn't it? But what do we know about probability? So for example, if we look at question C, we know about probability, it's a dangerous question to ask this lot. What's question C? The probability that X is greater than 65? Happy with that? We can do that in one of 2 ways. 50 to infinity, sorry, not 50 to infinity. 65 to infinity, we could shove our value in. Why don't we try and do that in a calculator?
Wait, how do you put that in your calculator?
Very good, thank you. So, my other class said you can make this number really, really big, which is an option. It's not the worst option, it's an option. You can make that really, really big so it acts like infinity. But if you wanted to be precise, and particularly if we were dealing with a tech-free exam, I could also represent this as 1 minus Px is less than 65. So I could say 1 minus 50 to 65 of my same function. Well, what's the total probability?
1.
So if I take away the probability that x is less than 65, that's the same as saying, well, that's the probability that x is greater than 65.
Wait, why is it 50 to 65?
Because that's the bottom of my function. Why do we do 0 to 1 here? Why do we do 0 to 0.75?
That's the domain.
Domain, so this domain starts at? 50. Cool?
But what if it was like x is greater than like 35?
Yeah, well then you make it 35.
35.
Yeah, 35 to 65.
Oh,
Cool?
yeah.
So whatever the bottom of the domain is, that's going to be the bottom integration.
Wait, would it be 65 if it would, or would it be 35 to 50? If it just said p x is greater than 35.
Well, if x is greater than 35, it's not possible in this scenario because that's everything. Because everything that's greater than 35 is also, like 50 is included in that. Cool? But if it went from x, if this was 35, then we change that bottom number to 35. Because that's the lower bound of our domain.
Okay.
Sweet. It'll make more sense with just a few cracks. Go through question 1 through to 3, and then we'll look at 4 later.